Hello, everyone. Just going to give everybody some time here to join. Give a couple minutes still, just let them in. Wondering where everybody's from in the chat here. We're located in Vancouver, BC here, enjoying the sunshine and snow that's coming along in the next couple of days. Okay, that's snow in the mountains, not necessarily in the city. Hopefully everybody's enjoying the winter season in North America, and for folks coming in from other jurisdictions, whether it's summer in the Southern Hemisphere, enjoying that as well. One more minute. Welcome to remote control. So for everybody that's on the call here, this is a regular series we run. This is the first one for 2022, I guess, is where we are now. They seem to have lost a year. It seems like everything is changing, and we're seeing people coming in from all kinds of places across Canada, and the United States and South Africa and the UK. So welcome, welcome. So remote control is a series we've been running for the last couple of years. It provides information and content to go and help people on smart infrastructure and smart opportunities. We've been dealing with things like utility services, smart building infrastructure, new ways of going through and running campuses, and all the other elements of cities as well. Today, what we're going to be talking about is how to fund your smart infrastructure project. It is remote control series number 14. For those people that are looking for more, we run these series once a month or once every 6 weeks. If you want to see any of the historical ones, we also record all of the old ones and are available in our blog area on our website if you'd like to hear additional content and receive any additional information from us. Please also like us on LinkedIn and on Twitter. We also go through and have a Twitter account, and we do social media there as well. But moving forward today, I want to thank Mr. Dr. Michael Lamoureux, who is our Vice President of Research and Lab Services, is going to be co-presenting with myself today. And what we're going to be covering off a little bit is give you a little rundown on what smart infrastructure is and what are some of the general natures of what we've done over the years with respect to it and some of the best practices around funding your smart infrastructure project. What Michael's going to share is some practical real-world example of how we've taken a research partnership from initial incubation stage through to much larger opportunities and where we're going, and give you a little real-world example of how it's done and what we can do around those. So as we go through this, feel free to drop into the chat if you have any questions. We have questions and answer sessions, so I'll be monitoring that, and we'll be able to answer as we go along, as we go forward. Usually we take around 30 to 45 minutes, usually done in about a 45-minute window. Give you back a little bit of the hour, and if there's any Q&A at the end, we will give you a chance to go through and ask some questions. So why don't we jump in? So how do we go through? And let me share with you a little bit as to what we think smart infrastructure is. So if you think about infrastructure in the world of information technology usually means networks, computers, desktop technology. In the world of cities, it includes water systems, wastewater systems, underground infrastructure, the roads infrastructure, and all those elements. In the world of a campus, it includes all the buildings. It includes all of the above ground infrastructure, including the electric systems, the distribution grids, and also any sort of gas infrastructure as well. So it's a lot of moving parts. Even when you're inside a hospital, you would be looking at it, and it could be including all the mobile equipment that's being moved around from emergency room to patient's room, etc. All of those pieces are part of the infrastructure that's being used in order to go through and run and deliver a service to a citizen or a student or a customer. So when we start looking at smart, what does the word smart mean? Well, it's really all about digitally enabling all of this infrastructure, and it's really driven by this whole new world of Internet of Things. Things that we look at that are being able to do autonomous control. We've got Tesla out here giving us cars that are self-driving, and those vehicles are becoming part of this new world of smart infrastructure. They're being able to go through and see where they're driving along. They're able to turn, they're able to back into a parking spot without us even having to touch the steering wheel. That's smart. It's using things like machine learning algorithms, artificial intelligence systems, and any sort of predictive analytics that goes with it. So that's the new world of the digital technology that we're seeing. And there's a whole big push on this called digital transformation, and everybody's coming up, and a lot of organizations are driving a new digital transformation strategy. Now, with all of that, when we think of smart infrastructure, though, we're also thinking of what is the outcome that we're trying to drive here. And the kind of outcomes we're looking for are looking at new ways that we can use this new digitally enabled infrastructure to drive operational efficiencies, and in some cases, even generate new revenue. So those are the kinds of things that we start looking at. And that's going to be a little bit of the theme that we look at when we start looking at cities, we start looking at campuses, and we start looking at buildings. And they're all those elements of smart and the pieces that we want to be driving here. So as we go forward, one of the things we've always been working with customers on over the last, I'm going to date myself, 30 years, is what is a smart city? What's a smart campus? So the reason we always couple campuses with cities is because a campus, especially an education campus, is actually a mini city. So if you take a municipality that's serving up a population of 20,000, most university campuses, big ones, have a student population that bursts up to anywhere between 20 and 50,000 students on campus. That's a mini city. What's interesting about most of these campuses is they all run underground infrastructure. They have transportation networks. They have buildings. They have residential, commercial, and industrial facilities on campus. So they have everything, but in a very small microcosm environment. So one of the things that we look at in smart cities and smart campuses is what are we trying to drive? Well, we're trying to improve, and these are words that came from a couple of different studies out here, and we've kind of coined them and brought them together. But it's all about increasing the livability and economics and through innovation using what I described earlier, artificial intelligence, new streaming data, secure environments for cloud. One of our last remote control series was, can you run your utility from home? The answer is yes. But how? Well, that's using things like security, doing private networks, and then able to go through and take real-time control systems and be able to go through and monitor your environment using that. The other thing that we're starting to see a lot is in the smart city world and the smart campus world is how do we go through and predict and optimize performance of all of our infrastructure systems? So as an example, if we're inside a room and we want to see air quality, and we want to basically make sure that we've got the airflow being optimized to clean the air through filters. How do we do that? World of COVID, that's kind of a key thing that we want to do to make sure that the rooms are safe in that environment. So we start looking at streaming data. We're able to go through and take an airflow sample. We're able to go through and monitor what's coming through that airflow, and we'll be able to go through and change all of the valves or all of the different mechanisms inside your HVAC systems to go through and handle those airflows. So those are some of the things that we look at in the way of predicting and optimizing what's going on. There's even areas in a smart city environment where is there a way that we can basically look at and monitor water quality? And can we also do that and predict any sort of anomalies inside our water flows as they're going through the sensors using things like real-time spectrometer analysis? So those are all elements for the vision of a smart city or a smart campus. Now, I've given you a lot, which is really infrastructure related. But one of the things we look at is there other ways that we can drive this, which are not as big, but very much more narrow in focus? And what are different ways that different organizations are driving this? Well, interestingly enough, we're running a Smart Series program right now where we've been talking, I think I've had about 30 calls with different cities and campus environments and been asking, it's like, what's your strategy today? What are you working on? And they range, and these initiatives that they have underway are in some cases as big as we're doing the whole city, all the way through to I've got a specific system in a transportation network and I'm trying to optimize this specific thing. Or down in Southern California, I'm in the middle of going through and working on pumps, and I'm looking at vibration analysis on just my pump inventory. Now, all of those are elements of SMART, and they're all things that we can basically be looking at in order to go through and create a project that we could do to test, validate, and then roll out new smart infrastructure technology. So let's look at that. Let's understand a little bit of some of the examples that I just talked about and how we can go through and look at them, looking at not just the world of the art of what's possible today, but the art of the future possible. So let me give you some examples. What we can see here is we have different kinds of examples of smart infrastructure. Some of the things that people and cities and campuses are looking at is, how can I create a mobile service on a phone for my customer? My customer in this case could be a student in the way of a campus, could be a resident in tunes of a city. So we've already looked at those of basically providing citizen services online. In the last 2 years, we've seen a rapid adoption of the ability to do everything in an online world. So how do we continue to do that? Not just on the net, but also with a mobile handheld device. I don't know how many people on the call here on this webinar have kids, but I do. My kids, they write their papers, they do all of their assignments on their phone. They don't actually use a computer. They write faster in class using their thumbs on their phone. So those are the new ways of this new expectation of what they're doing and how they're using technology. So some of the things we look at is there a way on a project that could be part of a smart infrastructure is providing visibility using a mobile handheld device, a mobile service. There's one. Now, as we start going along, well, what else is available in the way of new technology, or at least emerging technology? So I've worked in cities for 30 odd years, and we always been working with GIS systems, geographic information systems, maps. And on those maps, we always create different layers. So we have a base map, shows where all the roads are. We overlay on top of that where all of the fire hydrants are and all the roads are. And we can overlay on top of that where all the street lights and all of the different other systems on that. Well, that creates a 2D representation of the city or the campus. What we're starting to see is, how do we go and take that and start creating into 3D? So about 15 years ago, we were using a tool called Google SketchUp, and we are taking pump stations and we are creating 3D simulations and walkthroughs of the pump stations to look at that. Well, today, those are called digital twins. So when you start looking at that and looking at how those digital twins now work through in the way of a walkthrough, well, we're starting to create those digital twin infrastructure. And we then start saying, well, can I take all the readings coming from my real-time control systems and overlay it on that 3D virtualization environment of that? Well, our friends at Facebook, AKA now called Meta, have been calling this the metaverse. And the metaverse is just a digital simulation, but it's a fake world, whereas we like the real world. So we like the virtual worlds of a physical representation, but then able to go through and use that so that if you are running a utility from home, you're able to basically see everything, and you can use an avatar or be able to go and use the cameras inside the pump station to actually see what's going on. That's a digital twin simulation. There's another great example of smart infrastructure. Being able to go through and monitor that, and being able to go through and look at the operational systems, and it can be in a single environment, i.e. a data center or an operation center, or it can be virtual with virtual desktops that people can connect into as the operators and see what's going on and still do that. All right, so there's a bit bigger, a little bit more technology. Now we get into the world of green energy as an example. So what a lot of organizations are looking for on a global scale today is, can we deal with microgrids? And everybody says, well, microgrids are already there. Well, actually, yes and no. We have certain technology to create microgrids. We've got samples of microgrids, and we've got these other areas. But one of the key things we start looking at is this movement towards green infrastructure is creating a very complicated distributed energy environment. So we're basically generating power on our house, and we're having to go through and flip our distribution networks on our electric grids to reverse the flow of power. How do we do that? Well, that's where microgrids start coming into play. Now, what's interesting about that is, as I was working from a mobile, small little device to a digital twin of something that's looking at all the infrastructure, as we start getting into a green energy microgrid, we're now dealing with physical hardware, and we're dealing with solar systems, we're dealing with gas turbine systems, hard infrastructure assets as well. And so we start looking at these and we start looking at all of these different ways of dealing with smart infrastructure and the size of the projects. And one of the things we start looking at is, wow, there's a lot of tech here. And some of them are small, medium, large. And we want to understand, well, what are we debating? And part of this was, how do you fund your infrastructure project, the theme of our presentation? So the first we need to do is understand then, if we've got all these different examples of what the projects are, well, how big is that project going to be? So let's take a look back from the last one I just talked about, those three examples. If we got something like a mobile system, that project is it's probably less than $2 million. And it probably is going to take a certain time window to go through and do. Now, if we've got other projects where we're dealing with digital twins and simulations, well, those projects are going to be 2 to 25 million. They could take a much longer time window, but they're much bigger. I like the picture here that our marketing team put together, because that's the new world. It's all of those sensors. And if you start thinking about some of these mid-sized projects, or these 2 to 25 million, they're projects that could be done in a neighborhood. They're projects that can be taken in an area of a city or a smaller town that will actually validate with technology providers all the different elements of how all this technology works together. Pilot projects, proof of concept projects, and then production scale if it's a small enough city. And then we start getting into projects that have a lot of hard infrastructure assets with them as well. Those ones are 25 million to 100 million plus. Now, the reason I'm giving you the sizing is because funding is really driven by the size of the project. It's driven by whether it's soft infrastructure, i.e. building labor to go and build a mobile app, or whether it's a mixed commodity of hardware and software in the way of computer hardware and software, or whether it's in the world of actually also dealing with physical plant infrastructure as well. The more that you add elements, your funding envelopes change. And the things that you want to be discussing and looking at, depending upon the size of your project, the kind of project it is, and how complex it is going to define your funding model. So those are some of the things that we want to be looking at here. So let's go through and give you an example here of some of the funding models. And I'm going to work through a little bit and give you 3 ways that you can look at this, and then give you some specific tangible organizations. And then what Michael's going to do is give you an example of how we went through it through a couple of different stages. Okay, so let's look at the 3 funding models. So some of the things we look at is, number 1, self-funded. So if you're a city or a campus, you basically are dealing with things like operating revenue, a capital fund, reserve funds. If you've got a utility operation, you have bonds that you're able to go through and finance it, but you're going to be using your own balance sheet to fund it. And then there's grants, lots of them. Now, you'll notice the first word on here, tax revenue. Tax revenue in the municipal, provincial, and federal context is always there. So we always have to be aware, even if we're building physical plant, how much of that is going to be coming from upper, mid, or lower level governments that's coming from tax revenue. So we do have to be aware of that one. But self-funding, tax revenue is part of that. Whether it's a grant that's driven from tax revenue, we are always looking at those as self-funded programs. Okay. Now we have another one, which is what we call shared delivery. Shared delivery is where you have multiple parties sharing in the expenses and sharing in the revenue or cost savings associated with a common set of infrastructure systems. Okay. The world of cloud is enabling a lot more of shared delivery models for infrastructure. And so there's different ways of doing that. And then what we've seen over the years as well is what we call private-public partnerships. Different ways of building an ecosystem of partners that could be set up as a nonprofit alliance. It could be set up as a social corporation. It could also be set up as just a separate legal entity. But it usually has what we call a franchise contract attached to it that has a return on investment and a revenue stream attached to it. So if you're building an energy plant, there's a lot of funding available to go through and build that energy plant, so long as you have a customer at the end that's going to buy all the power that's being generated by the energy plant. Those ones are driven very much well towards a private-public partnership model. So let's look at this. If we've got these size of projects, these examples of projects, and these different funding envelopes, what are the best ways of funding your project? So we look at small projects, the ones that are less than 2 million, and the medium and large. And we look at things like, if we've got a small project, it's lower risk, It's got an ROI within 3 years, and it's a 3 to 12 month project. You can build a mobile app, or you can build a small little web-based application in 12 months, roll it out and have people using it, using agile development techniques and a whole bunch of other ones. So in those cases where it's a lower risk, it really makes a lot of sense to be using a self-funded model. You don't want to really be putting in all of the overhead and all the efforts to create this private-public partnership if you're only looking at $2 million and you've got a low risk and it's got a ROI in less than 3 years. But if we start looking at a large project, 100 million plus, and it's got an energy project and it's very risky, and we don't know exactly whether it's got some new technology in it and it needs to be validated, then some sort of private-public partnership model may make more sense. So what happens there is we're sharing the risk. We're going to share the rewards though, too. So because it's going to have a return on investment, and you can basically look at different ways of funding your large project. That includes things like debt, okay, or project finance. And I'm going to go through a little bit of that and explain what some of these sources are. Now, where I like the sweet spot that we found is medium projects, 2 to 25 million. Now, they are managed risk. They still link in where you basically have industry partners, academic and government partners all wanting to work together. So they work in a shared delivery model, but they also work in a private-public partnership. And you can also self-fund them depending upon how much you have in your capital reserves and how much risk you're willing to take. So a lot of projects in, say, IT or even the engineering departments, 2 million is reasonable, 5 million is reasonable when you've got hard infrastructure incorporated in that. Okay, if it's strictly labor, 2 to 5 is usually a range, but 5 to 10, 5 to 20 is usually when you start including a lot of hard infrastructure in that. So this little matrix helps to go through and give you the context. Where should you look and what is the mechanism or method you might want to look at to go through and fund your project? Now, let's look at some of the funding sources, okay? So one of the things I look at is we've been through things in the developing world. We've looked at different agencies in North America, and we always look at it and say, there's a lot of global institutions out here that provide a lot of money. So the World Bank is one, but you want to know, unless you're asking for $1 billion, don't go to the World Bank. Okay, so they have context, and they're always looking at something really large. They're usually looking at matching funds that go along with the Canadian Infrastructure Development Agency, USAID, the European equivalent, the African Development Bank. These are big project funding envelopes that are really geared towards hard infrastructure, not a lot of soft infrastructure, but they're available. And they're usually matching money to other organizations that basically have equity, or at least their own funds that they want to invest as well. All right, what about private foundations? Well, that's private money. This one's not run by government. It's not coming out of the federal agencies of the federal governments around the world, but it's coming from private individuals like the Gates Foundation or any other ones out there that are looking at their own mandates and using these as mechanisms to go through and fund projects or fund companies, depending upon what their mandate is. Now, what about, there's a third one, industry sectors. So the industry sector, if you go through, we go through different energy companies, and they all have an innovation group to them. One of them is Southern California Edison. So they're always looking for partners, industry or other academic partners that they can partner with to do demonstration or test projects, okay? And so they provide some of the funding in, and it gets matched. In the state and provincial Canada, there's things called the Innovation Clean Energy Fund. In the federal level, there's a thing at the federal level, there is things like the Green Fund out of the Federation of Canadian Municipalities, or there's Sustainable Development Technologies Canada. All of those are federal government, state and local, but they create these programmatic approaches for going through and funding projects. And what you have to be aware of is what those mandates are for those funds and align your project to that funding envelope. There's another one, financial markets. Well, one that we're aware of that we've seen a lot of traction on is green bonds. So if you're doing a green energy project or you're doing anything that's going to go and address climate change, then the green bonds are available. But there's also financial vehicles on the public markets that are looking at investing in projects, or they create portfolios of projects, and they will augment, in some cases, your state and local government money, but they will come in and be one of the players in a financial consortium to go through and fund your project. And then the last two, internal sources. Well, we talked about those. It's operating revenue, reserve funds, taxes. We've shared some of those already. And then the key one is if you are doing one of those larger 125 to $100 million energy projects, you always are going to have project revenue coming in. You're basically pre-selling somebody who wants to go and buy the power. And if you buy the power, what you're really doing is you now have a guaranteed revenue stream, and you can use that project revenue to go through and borrow money to build the project. Okay, so there's kind of the different funding sources. Now, what I want to share here is where do these sources make sense for size of project? Okay, so if we look at things like global institutions, they make sense for large projects. If we look on the far right as well, it's a small project. You're not going to have a lot of project revenue, but it makes sense for the large projects. And if you were to go through and link that together, a typical energy project in this model here, you're basically being able to go and link in some global institution, couple it with some federal grants, link it in with some bonds from the financial markets that are debt-based, and then use your project revenue to pay back the bonds. There's your funding envelope. All of a sudden, looking at this, you're able to go through and bring together 3 or 4 funding groups, and you can do a $150 to $250 million project. What about a small one? Well, if you do the same thing in a small one, you can go through and say, well, I can go and look at some private foundations, but really, according to our numbers here and the way our experience, you can bring in an industry partner who will provide some in-kind contributions. You can bring in some state and provincial funding. You can link it in with some grants from the federal government, and you might be able to use some of your own internal staff as your in-kind contribution for going and doing that small project. Wow, that all works. So what we've got here is a little bit of a grid that helps you go through and say, what's my project? What am I doing with it? Does it have hard infrastructure and soft infrastructure and staff? And then what kind of risk am I willing to take? And when you start doing that, when I start looking at the yellow are secondary sources. The green are, yeah, your primaries. And then the X's, you're probably not going to be successful if you go after and try and do something with a project of that size and that complexity for that specific example. So there's a little bit. So let me kind of recap for you. We've kind of gone through project size. We've gone through and described a little bit of what a smart city, smart campus looks like. Giving you a little rundown of some of the different kinds of funding sources available today, and then map the funding sources to the different kinds and sizes of projects that you're looking at. Well, now what I'd like to do is hand it over to Mr. Lamoureux here, Dr. Lamoureux, sorry, and let him share with you a little bit of experience as to how this works in the real world, okay? And use one of the projects as an example for that. Michael, over to you.
Thanks, Mark. So I want to talk about one of the projects we've been involved with in the last 5 or 6 years. It's an interesting project because it's progressed from these different levels of starting off with a small project. We're currently at the medium size, and we have a vision of moving up to a large project. So you'll get to see a little bit about how all these different projects come together and how you can actually grow a project from small to big. Let's go to the next slide. So this is at Ryerson University, which if you're not from Canada, it's let me know. It's centered in the center of Toronto, which we know is the center of the universe. So Ryerson University is a big campus with over 50,000 students and about 60 buildings. And the idea of the project is to turn this, the big vision is to turn this into an intelligent campus where the operations of all the buildings and utilities in the campus, which is right in downtown Toronto, this is all optimized using streaming data coming from IoT devices, the SCADA building systems and sensors that we have all around, collect that data and figure out how to run the university facilities in a more efficient way. Currently, we're working with 4 labs in Ryerson. One is specifically on buildings, so intelligent buildings. One is on the transportation systems in and around the university. One is on the utilities feeding the university. And then the final one is all about sensoring, so remote sensoring for the university. Well, let's pop down to the next slide. So here's a bit of the timeline. We're in the medium stage right now, stage 2, so this is a medium-sized project, but we didn't jump into that right away. We started off saying, okay, let's do something small with the researchers at Ryerson. So We worked with a woman in the architecture department, civil engineering architecture, and we did a small proof of concept. And the basic idea was, what can we do with IoT sensors? What kind of data can we gather about the building? And how do we feed that into a compute cloud so that we have all the data in one place where we can access and play around with it? So we didn't censor up a whole building. We didn't censor up a whole campus. We just censored one room, essentially her office, with all sorts of IoT sensors. So measuring things like the temperature, the carbon dioxide levels in the room, the lighting levels in the room. We can have occupancy sensors. There's lots you can do in a single room. But that was enough to give us a streaming data source that fed data into the cloud that we start doing some analysis. Now, this was a proof of concept. We showed the idea worked, that yes, you can actually grab data in an efficient way, make sure that you're not losing data, and save it in a safe place in the cloud. It was a small project, so it was mainly self-funded by ourselves at Fuse Forward, and then with some funding that came out of the university as well. So a small project, a little bit of research grants that come to the universities, and that made that all work. Stage two was to go ahead with a much larger project. So on the order of, I guess we're currently around $5 million of funding plus $5 million of support from industry and other partners in the project. This is a bigger project where we're actually censoring an entire building. So the building we're looking at is 29 stories tall. It's got some student residence in there. It's got some lecture rooms for classes, and it's also got professor offices and stuff. So it's a mixed use building. Got a lot of interesting data all about what's happening in the individual rooms. So things like the air temperature, the air quality, but also a lot of sensors on the equipment within the building. So the HVAC system, the water system, the electricity coming in, all that kind of stuff. The data is being gathered and it can be analyzed, and people can start taking a look at, how do we run this efficiently? The funding sources were different there. So we went to bigger sources like CFI, Canadian Foundation for Innovation, where we have a big alliance grant, which is from NSERC. So this is the Natural Sciences and Engineering Research Council, which is a big federal granting agency. We have a bunch of different companies involved that are putting in matching funds that generate the grant income for the project. And once we've done that building, the idea is to how do we go beyond? Well, Ryerson has 60 buildings, so you're not going to do that on a $5 million budget. If you want to try to make the entire campus smart, intelligent, and use that data, it's going to involve a bigger funding source. That's when we're going to start bringing in bigger federal grants, provincial grants to match, and so on. Maybe I can go on to the next slide, Mark. So here's a bit more about just about the campus. We want to create a digital twin of this one particular building. So you can see here, this is the Daphne Cockwell complex at Ryerson University. The top little gray part, that's the student residence. And then underneath it is so that's the student residence. Underneath is the professor's offices and some of the lecture rooms. The ground floor, I think, has commercial space as well as lecture rooms, big lecture rooms for the students. The advantage of the digital twin is you can actually simulate the building without having to do particular things with the building. So you can do, for instance, if you want to change the traffic flow pattern because you're worried about COVID infections, let's try to do something where you have certain stairs that are dedicated, that become one way. So you have upgoing stairs, and another part of the building you have downgoing stairs. Does that actually affect the air quality? Does it affect the transmission of the COVID virus? Well, that's something you don't want to test with real people. You'd like to test it in a digital simulation so you don't put people at risk while you play around with your ideas. But you can also do tests with the equipment, with the energy, and so on. Here's a second stage, which is the Smart Campus and Integration Testing Lab. So this is a new building that's being constructed on the Ryerson campus. It's a two-story building, but it's basically wired for sound. So it's going to be 100% digitally enabled. It's the world's first building that's completely digitally designed and implemented that way. It's going to be a test bed for researchers and companies to come in and try out equipment, plug it into the system, see what it does, collect the data, analyze it. And then the researchers can walk away with their data and their equipment, and the next group comes in and plays around with that. So this is a bigger project. So awarded $2 million from the Canadian Foundation for Innovation. That money is matched by the industry partners who are in the project. And we're actually looking for additional funding so that we can get more equipment and more activity happening within that project. Next slide, Mark. And this is some of the funding sources that we have for this. So at the top is NSERC, Natural Sciences and Engineering Research Council, Canadian Foundation for Innovation, CFI. We have provincial funds from Ontario, and of course the industry partners. We put our logo in here because we're giving the presentation, but we have about 20 industry partners all together in the project. So it's a big industry collaboration working on that particular project.
So Michael, that was very good. Thank you. Yep.
Yeah, send it back to you, Mark.
Thank you. So give you a little rundown, just to give you a little flavor. So we've done this for many years. That's why we kind of are trying to share some of our lessons learned as to what's gone along. So we've tapped into, in Canada, we've actually chatted with organizations down in Southern Africa, the World Bank, CETA, Export Development Canada, USAID. All of them have got different methods and processes to drive through. So this just gives you a laundry list of some of the examples of things that we've done over the years and different funding that we've obtained. So we use things like MyTax for real-time facility analytics visualization, small little projects focused on using students that fund students and a professor at a lab to go and do some experimentation. Great. Those ones are great. And then we've got other things in here which are fully much larger, like a federated cloud HR system pilot project for the Department of National Defense. There's a program out there. They put a challenge out there and said, can you solve this problem for us? We don't know how to do it. So we are into a second, third phase of that one and building those ones out using things like the IDEAS program out of the federal government. And Kingston, some of the stuff we did back in the mid 2007, 2011, or 2012 was with Sustainable Development Technology Canada. We actually took an area of the city, dug up corners, put in district flow meters in the water wastewater systems, and then extended and looked at the smart metering infrastructure on gas, electric, water, and wastewater meters. And we looked for different ways of doing profile analysis for all the systems inside those areas. Well, that was done with a pilot project out in the field. So this kind of gives you a little bit. It's like, wow, there's a lot of stuff out here and there is a lot of funding envelopes. We've learned a lot over the years on how to do this. But there is some things that you can do around what is the best practices to do that. So let me share some of the lessons learned. So when you look at best practice, one of the things that we've learned, make sure that you are aligning your project to your funding envelope. That means don't go to a program that has a $2 million cap for the largest project and ask for $5 million, okay? If they sit here and say, hey, we're only gonna fund 43%, by the way, that is a magic number, 43%, we wanna match that number with industry and with other cash contributions. Don't go to the cap, try and drop it down to say 40%, but work within their parameters. Understand what the funding envelopes and the funding sources are knowing. And this gets into the other points here. Know your funding sources and mandate and what their investment horizons are. So if we're dealing with something like a green bond and we're building an energy plant, well, actually, that money is very patient. And what they're really looking for is they're looking for a long-term return on investment with ongoing dividend yield. So if you know that their investment horizon is 15 to 25 years, don't try and only bring them in for 3 to 4 years to do the project and try and get them out. Let them ride the wave. So you want to bring them in for the right time horizons as well. Scope your project with tangible milestones. So what does that mean? Well, that's kind of, if you work on it, a lot of the programs, especially when there's a grant or some sort of other program, they always have annual or quarterly or semi-annual reporting requirements. And they have things that they have to report back in the way of their performance milestones. So you want to link your program into, or your project into their program mandate, their milestones, and structure your project so that you can report back your milestones that are linked to their performance indicators. One thing we've also learned, a lot of people struggle with soft infrastructure. What does that mean? paying for people, paying for software. What they really liked, and what a lot of those ones like the Canadian Foundation for Innovation and other ones, they always, or anybody that wants to invest in a green project or something like the World Bank and the big global institutions, they want to see hard infrastructure in there. So they want to see people buying solar plants. They want to see turbines. They want physical plant incorporated into it. So long as you can incorporate both the soft and the hard together, the larger the project, the better to incorporate some hard infrastructure into the project scope in order to go through and help facilitate alternative financing vehicles as well. And then the other one, and this is whether it's a grant, whether it's something, always understand your return on investment model. So investors may be financial investors, but investors are also city councils. Investors are also managers that have a capital program, that have a business case they have to meet. Those are your investors. So always think about structuring your project with return on investment, look at your benefit case, and be able to quantify your benefits to create a return on investment formula. So some key themes we've also heard. So over the last 2 years, digital health advancement and pandemic management have been the hottest buttons out there. Surprise, surprise. But what's now coming along, and what we're seeing a lot of traction on, is the new world of Internet of Things and industrial Internet of Things, machine learning and artificial intelligence. And then we've got trillions of dollars, notice trillions of dollars, looking at grow back better, okay? Green infrastructure investments, alternative energy and decarbonization of the economy. Those key things right now are creating new jobs out in the field for trades, new training of trades to use green infrastructure. And there's a lot more programs being initiated by the federal governments out in the world, including the provincial governments in the way of green trade programs as well, that are all focused on the middle three. The first two are really key areas for what they call highly qualified personnel. So the more that you can quantify your project into HQPs, key metric, highly qualified personnel trained in machine learning, artificial intelligence, Internet of Things, that's great. The more you can target your project and incorporate a relationship or some partnerships around green infrastructure, building green trades for alternative energy and decarbonization, great. That's going to help facilitate and get you a lot more tick boxes. And then the other one is pandemic management and the whole new ways of dealing with decision support systems that are more quantifiable than qualitative in the way of managing it, and then how we can look at new ways of doing digital health advancement. Okay, so those are all the kind of key trends that we're seeing today. Now, what we get around that is then just reiterate, remember, if you've now got all these key trends, every single one of these funding sources that I talked about earlier has mandates and programs linked into one of those key funding themes, has a time horizon that they're addressing with respect to they want their money invested, and has the size and significance of projects that they want to go through and invest in. So if this is, we've given you a lot of material here and a lot of information. Hopefully that's been useful. I hope that it kind of gives you a little bit of food for thought as to how to go through and scope your project. If you're looking for some help and you're looking for ways to go through and do this and would like to reach out, feel free to reach out to us. We are providing free workshops for smart infrastructure projects to help you with the scoping, helping you with business case, and giving you the ideas and our lessons learned. We've done this, as you've probably seen, for 13, 15 years. So we've learned a lot, got a lot of scars on our back for what works, what doesn't work, and especially what doesn't work, how to go and create consortiums, alliances, how to bring industry partners together, how to bring academic partners together, and then link them in with your cities and your campus environments and the people that are actually running the actual in-field plant environments. So that kind of gives you a little bit. I want to open it up for some questions. If anybody's got any questions, happy to answer or provide any feedback. Welcome some information on that. And if you also want to learn about our SME infrastructure program, feel free to reach out to Dr. Michael or myself, and we'll be happy to go through and link you in. And they're all on the website. All right. I'm not seeing a lot of questions from the chat, so hopefully this was an informative session for everybody. And we'll give you back a little bit of time. Oh, maybe there is a Q&A. Cooperative utilities in the United States and how do I fund? So we've actually, interestingly enough, on that one right now, Deborah, is we've been in discussions with a consortium down south of the border for us in Missouri, and there's a lot of the public utilities commissions down there. One of the things we look at is how can you go through and link in with some of your suppliers in order to go and do those projects. First one is, what is it that you're willing to provide in the way of a cooperative utility, and what do you have as the way of your key assets that something like an industry partner would be interested in working with you on? Is there, so they're willing to look at, especially your size, if there's certain specific things and there's a good way to validate it, there's one opportunity. Is there other ways to go through and fund? Absolutely. And if you need some help on this, please reach out and we'd be happy to go through and come forward and try and address some of those with you. But there's definitely ways to go through and fund your project as a cooperative, including the new programs coming out from the federal government of the US for the new infrastructure investments coming forward. Any other questions? Everyone, we'll give you back a little bit of time. I hope that this was informative, and we will reach out, and please reach back to us, and we look forward to being in contact. Thanks.
Thanks, everybody.